So we need the partial derivative with respect to x, and then the partial derivative with respect to u. All right, let's do x first. If I want to take the partial derivative with respect to x, what rule do you think we should use here?
Quotient.
Okay, good. Use the quotient rule. So do you remember how the quotient rule goes?
Low denominator, low times the low times low d high minus high d low, all of the denominator squared.
Okay, good. So low d high minus high d low over low squared. So I have the denominator as the low, and then what's the derivative of the numerator? E to the x minus top one times the derivative of the bottom. What's the derivative of the bottom with respect to x? Okay, good. So next to the 6th power. And then it's all over the bottom squared. We could attempt to simplify this some, but I don't need you to do that. This is fine for your answer for that. And then if we want to take the derivative with respect to u, we can use the quotient rule there as well. If we do that and I take the derivative of the top right here with respect to u, what would that be? Yeah, it would be 0. So this first term will go away, and I'll have something like minus something times something over something squared. So if we did it with the quotient rule, which would be fine, it would look like that. Or we can think of it like this. This is the same thing as e to the x times u plus x to the 7th to the minus 1. E to the x, the reason I'm doing this is because e to the x is constant. And now I can just use the chain rule here. And when I use the chain rule, the negative 1 comes out down in front, so I get negative e to the x times u plus x to the 7th raised to what power? Negative 2, good. You subtract 1 from the power. And then what else do I have to do to this to finish it up? Yeah, how do I finish up the chain rule here?
Derivative of the inside, so it would be 1.
Okay, good. Multiplied by the derivative of the inside, which is just 1, because we're taking the derivative with respect to u. And now you can see we're getting what we expected. We're getting just one term in the numerator basically over u plus x to the 7th squared. And then in the top, you have this term times this term. So you can leave it like this. You could rewrite it if you want to. And that's all you need to do for the first partial derivatives. If you were asked to find all of the second partial derivatives in this particular problem, then the list that you need to go through is take the first partial derivatives and then take the derivative of each one with respect to each variable. So you'll end up with four different derivatives. It would be wxx, wxu, wux, and wuu. And there's a special relationship between these two. Have you guys seen what the relationship is between these two? Yeah, they're always the same as long as your function behaves reasonably well. And there's a technical way to define behaving reasonably well that we're not going to talk about, but it can be useful if you happen to go into upper level mathematics, then you can go back and look at what the details are for that.